Good evening all, good evening all, good evening guys. Is my voice is clear and is my screen is visible? No sound. My voice is not clear? Is my audible? Anyone in the chat box? Is my voice is clear? Then we will get into today's session. Good evening. Okay. Okay. Good evening all. Good evening, Karan. Good evening all guys. Okay. Okay, we will start the class within 2 minutes. We will wait for the students to join this classes. Okay, voice is clear. Thank you guys. Good evening. RJ has some knowledge with PIC 16F. Good evening, Philip. Good evening. Good evening, Santosh. Good evening. Okay, we will get into the slide. Okay. So, good evening, everyone. This is Ari from Panda learning. So, we are going to enter into the first session for embedded systems, which is based on ARM-Cortex, M family, M4. Okay. So, this class is going to be 30 days. So, we will get into the class. So, today we are going to see we will see what is ARM, we will see STM32 controller introduction to STM32, and we will set up the KEIL ID. Okay. First, we have to know why this course. Why you are studying? What is the reason to see this? Reason for studying these 30 days of masterclass? So, what is the reason for it? Okay. So, this course is based on advanced embedded systems for 30 days. So, it is based on STM32, based on ARM-Cortex M4 family. So, it is a industrial application microcontroller based controller. So, this course is going to be very much useful for the students and the guys who want to change to the embedded domain. So, lots of things. So, we will see one by one. Okay. So, first we will see what you can expect from this course. So, by 30 days of completing this 30 days of masterclass, what is the knowledge you're going to gain? What is the use of this course? So, you will learn advanced embedded systems and you will get a knowledge to develop the high quality embedded systems. And you will learn lots of core concepts like timer, UART, I2Cs, like communication protocols and everything. And in this masterclass is special because we are not, when we take STM32, we have a all library. So everywhere you can see randomly they will use a all library. All library means it is like an Arduino. In Arduino we will have lots of inbuilt functions, right? So we are not going to use the all library. So it is an advanced library. So we are not going to use. So we are going to use we are going to code with registers by using the registers, because when we use using the registers, then you will know the backend process of this. Because when you take Arduino, when you take Node MCU, if you want to communicate in UART communication, if you want to send some data in UART communication, means you will just given a function which will be a serial print. So you will not understand what is the background process going on. When you come with when you use to registers configuration, then you will know how the UART is communicating and what is the backend process, how the bits are transferred and how it is getting settled and how it is complete backend process you will learn. So for this purpose only, we are choose the STM32 controller by we are going to code it using the registers. So it is going to be a good knowledge. It will give you a good knowledge and provide you a good skill of developing a embedded system. Okay. Then we will see the idea, KEIL IDE development, integrated development environment. We will see how to use that development, and we will see lots of advanced communication protocols. I will come in this next slide, and we will going to see the lots of hands-on coding. So we are going to develop lots of code for the core concepts and communication protocols, and we will also develop some projects. Find out this thing. What is output we need. So we need to develop some project using STM32. So we will learn all the concepts and we will implement in some projects by developing a project based on STM32. Okay, and we will learn the fundamental concepts and you can expect a support from us. So you can ask questions, and if you not understand, you can you can message in chat box. If you understand means you can give a art or like answer like stickers. So it will be very much support and we will provide you a complete support for you. Okay. Then we have to know why we have choose STM32 microcontroller. Why we have choose? Because we have lots of Arduino, PIC, Node MCU, Raspberry Pi, lots of things are there. Why we have choose STM32? When, as I said in previous slide, when you come with Arduino, Node MCU, Raspberry Pi, everything has some of more advanced inbuilt functions and inbuilt libraries. So you will not able to understand how it is working and what is the backend process going on. So when you come with Raspberry Pi, if you learn this STM controller and next you are going to develop with the Raspberry Pi means there will be easy functions will be available to configure this. So the code will be not that much bigger than like compared to STM, but you will not know what is the process going on background. So when you learn this STM32 with using the registers, and you will know how the background is working, and when you are shifting into Raspberry Pi, then it will be easy to understand and you will be getting used to it. Okay, so that is the one reason, and it is a STM32 is mainly concentrated on industrial. It is an industrial controller because in all industries nowadays the STM32s are very much used commonly. So it is an industrial applicationable controller. And when you are learning with STM32, it will provide a valuable skills which will be very much useful for learning the other microcontrollers, variety of microcontrollers, because you will have lots of features and functions in this STM32. When you came to know used to this controller means it will be very much useful for you to move to the next controllers, and it will be very much easy to understand the registers how it is working. So we are going to focus on we are going to code using registers only. So that will make you very much knowledgeable and skilled. And we will see the advanced features like USB, OTG, DCMI communication, like that. We are going to see lots of them. And as I said, we are going to understand the backend process how it is working. Not we are going to simply use a serial print function to send a character like that process. Okay, we are going to set by bitwise, which will helpful for the students and the guys to understand the background process, because by understanding that only you will be able to develop a particular different new projects. For that purpose only we are using we are selected the STM32 microcontroller, which is based on ARM-Cortex. Okay. So next, what is the expected from you? What is the thing I am expecting from you? So give time, spend time with this course, come to the class correctly, and concentrate for this 1 hour. And you should have a strong drive and willingness to learn. And you should have a every day of practice. Okay, because everyday practice makes a man perfect. So you should practice for every day. Okay. And you should need a consistency. So this masterclass is going to be for 30 days. So you are for 30 days, every day you will have a 1 hour. So if you consistently learn for everyday practice means for 30 days, it will be a good knowledge and it will be change by yourself itself. You will be get used to it and the logical skills will be improved. So that is the focus on this main masterclass. Okay. And this course is focused on for the students who was like to enter in the core domains like EC students and EEE students, and those who the guys who like to get into the embedded domain, and the companies who like took place in like Robert Bosch, like these companies. So for that, focus on the students and the working, also for the working professionals and job seekers. So for job seekers who are like to change the domain into a embedded system. So for that purpose also. So and we will it is focus on consistency of learning, as I said before. So in whatever the thing you learn, you should need a consistency. So consistency will make you very much skilled. Okay. So we need a consistency. So now who is this guy? So myself Srihari from Panda elearning. I have good experience with the embedded system for past 2 years, and I have worked in lots of microcontrollers and projects. So today I am going to give you I am going to handle the 30 days master class. So I will guide you and I will give a good knowledge and skill for this 30 days class, and it will be very much useful. Okay. So this is the announcement, guys. So the attendance form will be provided at 7:45 p.m. So if you guys this masterclass will provide a e-certificate for you. It is what is the requirement is you should have 25 days of attendance. So don't miss this class. So guys, use this opportunity to upskill yourself. Okay. So now we will come to embedded learning plan. Okay. So first we will see the STM32. What are the peripherals we have? What are the core concepts in the STM32 and what are the communication protocols? We will see all the core concepts in the STM32, and we will see the communication protocols. We will we will make communication between some two peripherals or some devices, and like LoRa, and finally we will create a project by learning this controller based on this controller. Okay. So this is a day-wise training. So first day, this is the plan for 30 days. Okay. So first we will see what is STM, and we will see KEIL Vision ID, and we will see the clock setups, timers, and UART communications, I2C communications, SPA communication, and what is ADC? ADC means it is a analog to digital converter. So ADC is with multiple channels, and PLL it is for an integrated sound. So STMs can be also used for the sound purposes. We will see that in the coming slides, and we are going to use the compare capture PWM. By using that function, we are going to interface the ultrasonic sensor and temperature sensor with the STM32. Okay. And we are going to configure RTC. What is RTC? It is a real-time clock. And we are going to see DMA. What is DMA? It is a direct access memory. Okay. And we will see the USB, and we are going to interface a DCMI. We are going to see DCMI communications and random number generator programs, and we have a DAC and lots of variables. So interrupts, LoRa, and we are going to interface LoRa, and we are going to create some projects. So these are the 30 days wise planning. Okay. So now before we entering into a microcontroller, first we should know what is embedded system. So what is embedded system? So connecting everyday things with the electronic softwares and sensors to the internet, or it can be with internet or without internet. With internet means it is called as an IoT. Without internet means it is a embedded systems. Everything will be come under the embedded systems only. So like what is the process? The embedded system is to do some specific operation on multiple tasks. That is what embedded system is, without the help of the human interaction. So this embedded system, by configuring and developing embedded system, what is the benefits? So by enabling the device, we can collect and exchange the data without humans. So nowadays you would have been come to see in lots of technologies around you. So it is all communicating and collecting and exchanging data without the human interaction. So that is what called as an embedded systems. Like we have when we take our smartphones, we have GPS locations, voice detection, face detection, and brightness, adjusting of brightness. So these all comes under the embedded systems only. How it works? For a simple example, my phone brightness is adjusted as per my GPS location. That is what embedded system is. There is no required for human interaction, and automatically the controller will, the embedded system will collect and exchange the data to do some specific operation or multiple tasks. That is what embedded system is. Okay. So like what are the tasks? Like smartwatch, we can consider a smartwatch. Smartwatch is a good embedded system. In When you take day-to-day life, you can see everywhere there's embedded system. If you take a computer laptop, it is also built on embedded systems, monitors, TVs, smartwatches. Everything is built on the under the embedded system, because nothing can work without the IC or a process or controllers. So everything is built on the embedded system only. So smartwatch is a good example, and other applications for like a GPS system, fitness tracker, ATMs, and home securities. Now home security is getting updated. So you can see this. So lots of homes are getting implementing this security system. It is all comes under the IoT or embedded systems. Both are same. Okay. So we will come into ARM-Cortex microcontroller. So in this 30 days of masterclass, we are going to see is ARM-Cortex M4 microcontroller. So this is a microcontroller based on ARM manufacturers. So we will get into it. So we have to know what is the application of it, because we have to know what is the microcontroller can do and what are the opportunities and why should we learn it as a effective of learning. So for that, what is the applications? So as I said before in the class, it is an industrial controller. So it is widely used for IoTs, automotives, aerospace, and defense, and energy management, and lots of there are there. So by learning the ARM-Cortex M processor, so can open up the many career opportunities in these industries. Okay, and it can be. And second point is efficient processing. So this ARM processor is designed for a efficient processing with a low power consumption and making them ideal for the battery powered devices and the application that require for a long battery life. So this is another reason. And real time processing. So like when you take EVs, there all we need a real time processing. So if there is a met with an accident, means there should be a immediate initiation of airbag open. So for that there should be a real time processing. For that also the ARM-Cortex M is used, and the scalability. So as per the required for hobbyist, as per the students, we can it is scalable, and we can. What are the futures? Because if you take ARM-Cortex M, it has lots of futures. But when you are designing a project for industry, means it does not need lots of futures which is present in ARM-Cortex M4. So we can scalable, scalable. What are the requirements? As per the requirements, we can use the futures alone. We don't need extra futures. So it is highly scalable. So no problem. So it will be very much useful for you by reducing the size, by reducing the rate, and like that cost wise everything will be reduced. And the industrial standard. So this ARM-Cortex is an industrial standard with many development rules like library, documentations, and learning ARM-Cortex M processor can be provide a solid foundation for working with the other microcontroller architectures. So as I said before, so by learning this, you will get used to other controller very easily. So that is another reason, and it is very much affordable for the students and hobbyists who are trying to develop the projects. So and it is open source. It is open sourcely available. So these are the reasons why we are learning the ARM-Cortex M. So when you take ARM-Cortex M, we have a variety of Cortex M, variety of M family in the ARM. So we have, it is range from 0 to 7. So we are going to use this ARM-Cortex M4. So it has a special features for digital signal control, processor with DSP. DSP means digital signal processing, and accelerated SMID, and floating point. So floating points are used for the calculations. So for the precise calculations. So we are going to see what is ARM-Cortex. Okay. Before that, we should know what is ARM. So ARMs are manufacturers of these kinds of controllers. So the manufacturers have different three varieties of controllers. One is for application, one is for real time, one is for microcontrollers. So applications. So now we will see what are the use. So first we will see ARM-Cortex EA. This is for applications like developing Android. It is powerful as we can develop Android and Linux like software OS in the ARM-Cortex application wise, because it is like a processor in the computer like a Snapdragon, like Intel. So it can do a multiple process, and it is more and more efficient. So that is the application processor. So these are used in the smartphones and for creating Android like that things. Next we will come to ARM-Cortex. What is ARM means? It is a real-time application. As I said to you in the before slide, the like using in EVs and cars and all the cars, we will use the real-time controllers, real-time process only. So these two are processors. When we come with the ARM-Cortex-M, it is a controller. So when you come with ARM-Cortex-R, then it is a real-time application. It is for real-time. So it is widely used in car vehicle industries, automotive industries, like that. So by learning this ARM, you will have more opportunities in the open world. And what is the thing we are going to learn? We are going to learn is ARM-Cortex-M. So when you compare with the ARM-Cortex-M, it is a microcontroller. So with the lots of features, it will give you a lots of opportunity to develop some of the projects by your own self. So it is making nowadays Cortex-M is making a revolution, and lots of industry are using the ARM Cortex-M because it is giving you lots of features in the one controller. So that is the reason, and it is it is based on the ARM architecture. Okay. So when if you take Raspberry Pi means it would have been built on the ARM architecture only. Not on it is not purely ARM Cortex of A, but it is built on the ARM Cortex A's architecture. So it is based on those architectures. They would have been get license from the ARM manufacturers, and they have been created their own IC. What are the features they need? They can create themselves. That is what scalability is. Like that wise, we have a 3 series A, R, and M. Okay. So this is the Cortex A is used for highest performance, like gaming systems, like Xbox, like these things. When it comes with Cortex R means it's a real-time application. So it will do a fast response, optimized for high performance and for real-time applications like EVs, robotics, and like manufactured robotic arms, like that things. When you come with Cortex-M means it is designed in the smallest and lowest power consumption. It is so efficient. So optimized for processing and microcontrollers. So it is like smartwatch. We can see it in smartwatch, headphones, and like IoT home automations, like that. Lot of things we can do. It will have lots of opportunity to do lots of things. Okay, so that's why we are seeing the ARM Cortex. Okay. Okay. Now what we have to do is first we are getting into controller means we have to know what are the futures of the controllers, because while we are getting into a new controller, we have to know what are the futures present in there, what are the things we can do with it, what are the things it can do, perform. So we have to know all the things, how it works. So we have to know first, whenever you go with a new controller, first you should know the futures of the controllers. Okay. So this architecture is based on ARM v7M. And as I said, it has a floating point unit. It is used for precise calculations. And we can it as an up to 4 GB of addressable memory and 1 MB of flash memory and 192 KB of SRAM. And it can also support the external memory SDM and NAND flash. NAND flash means without the help of the controller, it can store the data in the memory. That's what NAND flash is. Okay. And we have up to 240 of interrupts and timers. The timer systems, watchdog timers, and up to 12 general purpose timers are available here. And when we come with the communication interface, it has a SPI, which is a serial peripheral interface, and we have I2C, inter-integrated communication, and we have USART and UART, both with the synchronous and asynchronous. Both the way. Synchronous means it will transfer the data with the clock pulse. Asynchronous means it will transfer the data without the clock pulse. So we have both the futures, and we have a USB. It's a universal serial bus communication. And we have a memory protection unit. When you come with the security, we have options like a memory protection unit, secure root process, hardware, accelerated cryptography engine. And the main thing focused on the STM32f407xx is power management. So it can be work on more and more low power consumption. It will take only less of power. We can operate this in a low power mode also. So that is the main reason. It is a good future in this control. Okay. So now we will detail see the how many the UARTs present, how much the ADC are there. We will see detailedly the futures. Okay. So first is what is the core? It is running in the M4 CPU with floating point unit and digital signal processing. So what is word length? Word length means the microcontroller can write and read the data in 32 bit of word length. So that is what word length is. So it is word length is 32 bit. And what is the main crystal we are used is 8 megahertz. Okay. And we will come to the futures. So ADC, we have 3 12-bit ADCs up to 24 channels. In the 3 12-bit ADCs, we have up to 24 channels, and we have 2 DACs. DACs means digital to analog converter. ADC means analog to digital converter. So we have 2 DACs with 12-bit, and we have a direct memory access, which is as a 16 streams of direct memory access. And we have, when we come with timers, we have 12 16-bit timers and 2 32-bit timers. And in that future itself, we have 4 compare, 4 capture, and 4 PWM. PWM means pulse width modulation. So next we will have a communication protocols. It is we have 3 I2Cs, 4 UARTs, 2 UART, which is synchronous and asynchronous, and we have 3 SPIs, 2 CAN. CAN means control area network, and SDIO interface. You can use your SD card to upload the code also. And we have advanced communication like USB 2.0 and Ethernet. And we have a DCMI of interface of 8 to 14-bit parallel camera interface, and we have a random number generator, and we have a calculator CRC, which is a calculation unit. So floating point is used to do a precise calculation. So these both come under the same, and we have an RTC crystal of 32 kilohertz, and as per the main crystal is 8 megahertz. Okay. So then we have to know what are the extent we can do with this, what are the advanced projects have been developed with it, and what are the things we can do with it. So that's we are going to now see. Okay. So first is digital signal processing, so DSP. So as I said in the previous slide, we can process the audio also in this by using the STM32 controller. Like we can use the audio processing, speech recognition, and image processing like this things also by using the STM32 controller. Okay. And when we come with robotics, you can interface cameras, lidars, ultrasonic sensors, and the control algorithm for precise motion controls like robotics applications, like that processors. When you come to the industrial automation, the programmable logic controls, motor control systems, remote monitoring systems, like this things also used in the industrial automations. So there are the controller used as these functions. And when it is also used in the aerospace and defense, avionics means aerospace plus electronics is called avionics systems, like communication, what is altitude it is traveling, like that, all the things, navigation, flight control, communication. And we also use for the defense sectors like unmanned aerial vehicles and missile guidance systems. So that's why we are using the learning the STM32 controller, because it opens a variety of opportunities and many opportunities for the students and those guys who like to enter into an embedded domain. Okay. So, and when it comes to the IoT, we can connect we can develop smart sensors, wearables, smart homes, Wi-Fi, Bluetooth, and Zigbee, like these things. And when we come with the medical devices, implant medical devices, remote patient monitoring, wearable tracker. So these are also the things. It is on the all the fields. So we have 6 fields here. Okay, we have 7 fields here. The controller is used in these all the fields. So you have all the fields of opportunity, and you can develop the what are the field, if you, in this field, what are the field you like, you can develop the project based on those fields. And when you come with the automotive, we have ECUs. ECUs are present in all the bikes and cars. And we have infotainment. Infotainment is like a dashboard, like when you have seen the car dashboard, right? Like that system. Drive assistance that Tesla using. That is what drive assistance. And CAN means control area network, and then local interconnector network. So these are the things which is used to communicate inside the vehicles, cars. So and Ethernet is available. So it can be, you can configure or develop what are the projects you need. So it has lots of variety of opportunities and lot of futures. Okay, so that's the reason why we are getting into the STM32 control. Okay, so in summary, by learning STM32, you will be able to gain a valuable skills which will be used to learn other controllers or to use to create a variety of opportunity for you in the open world. Okay. So you can now convert this masterclass into an internship. So we are going to provide a 1 month after this 30 days of masterclass. We are going to provide a 1 month of internship on embedded systems. So not like a YouTube live, it is going to be one-to-one. So you can ask questions in a middle of the class, and I'm the one who is going to handle those classes also. So you can ask directly questions and I can reply to it, and you will have an expanded things of explanation, because when it comes to live, I will be giving lots of information. When it comes to the internship, I will be adding some lots of information to it. So by internship, you can you are going to develop a project, and you can get used to what are the questions, and you will get a gain more knowledge based on the STM controller. So guys, fees is 1200. So we have a discount by using this coupon. We have a internship fees of 691. So use this internship after this 30 days of masterclass to get more knowledge in the STM32 controller. Okay. So what are the benefits of internship? So we will do a 30 days of live session, and you will get a 90 days of access to records, because if you want to try some things, means if you have any errors, means you can refer to those videos. So you will have a 90 days of access to the records, and hands-on practice of embedded projects you will get, and you will downloadable 30 presentations you will be downloadable, and very much advanced and very much good thing is you will get a 6 mentor live in master sessions. Okay. So we will have every week we will have a one-to-one live sessions. So you can ask questions directly, like Q&A, whatever things you like to know, you like to ask, you can ask there. So this masterclass, this internship will be very much useful for you, and you have an internship confirmation letter, and final after the end of the internship we will provide a internship certification for you. So very much useful for getting placed in other water embedded companies. Okay. Okay, how to register? So this is the link. So guys, use this registration link for registering for this masterclass. So those fees is 1200, and the coupon is, this is a coupon. Use this coupon for discount, and you will, the fees is 699. So guys, use this opportunity and register for this join for the internship users. So use this opportunity to get more knowledge in the STM32 controller. Okay. 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 Now we will get into the STM32f407xx. So we are going to see is STM32f4, which is based on ARM-Cortex M4. Okay. So first we will see the description. So first thing you have to know is, first what are the control you have taken. You have to know is the pinouts. Okay. So these are the pinouts. So in this STM32f4, we have three varieties of pinouts. We have a 100 pin board, we have a 144 pin board, and we have a 176 pin boards. We are using is 100 pin board. Okay. So as you see, yeah. So like Arduino, like pick, we don't have every function in a single pin. So in this controller, when you take this controller, in every pin, it has a minimum of 2 functions to maximum of 4 functions. Like this, if you take a PC2 pin, means it has an SPI communication also. It has an ADC analog input also. So like that, when you take a PA of 4, means 4th pin, means it has an analog output also. We can configure it as an analog output also, and analog input also, like that. PWM, serial RX, like this things. So every pin will have a minimum of 2 function to 4 functions. So you can see I2C, CAN, PWM, so, and another one is GPIO, general purpose output, means you can also use this pin as a GPIO, general purpose output. So for general purpose output means for like a blinking LED, like that processes. Okay. So this is a thing. First of all, you have to know about what are the pinouts. Okay. So we have an 100 pins here. So we have a port of till H. We have 5 ports. So these are the pinouts. So we have 4 functions each. And now we will see the block diagram. Okay. So when you see the block diagram, you can see that we have a port of till I, and it is connected to the AHB1 bus, and we have 2 buses, which is AHB1 and AHB2, and we have an ABB1 and ABB2. So ABB1 bus has been connected to this UART timers, all these things. So when we are getting into code, we have to know what if I am configure UART, means I have to UART. You see UART2 means I have to know what is the bus it is connected to. It is connected to ABB1 bus. Okay. So we have to know this all the configurations. Okay. So next. Okay. So as I said to you before, so we are not going to use the all library for programming. So we are going to use the registers for programming. So as per the STM32 is world length is 32-bit. So it can read and write the bit in 32-bit form. Okay. So consider this is a 32-bit from 0 to 31. So it is a 32-bit. So each this 32-bit is divided into 8 columns. Each column consists of 4 bits. So if I will take this scenario, so we are going to set 1 in all the bits. To set all 1 in all the bits, what we have to do? So if you consider, we are going to place all the bits with the 1. So it will the bit is separated into 8, 4, 2, 1. So if I want to set this 4, 30, 1, 30, 29 and 8. If I want to set this 4 bit also means, then I have to give the sum of this 4 values. So what is the sum of the 4 values? 8 plus 2, 10 and 4 bits, it is 15. So 15 means that now what it comes with means the controller can't understand the digit 15. So when it comes to the microcontroller, till 9 it will be in an integer. When it comes with 10, it will be represented as A. When it comes with 11 means it will represent as B. Like that till 15. So 15 means it is represented as F. So if I want to set all the logic 1 in all the pins means I am going to go. So 32 bit is divided into 8 columns. So that means we will have 8 integers, 8 zeros here. So for that, if I give 8 zeros means the logic 0 only it is going to set in all the bits. So if I am going to say, I have to say what we have to do. So we have to do is we have to set the logic 1 in all the bits. So for that, we are going to give a FF. What is F represents? F represents 15. So 15 means it will give the sum of this value. So it will set the 1 in these 4 bits, all these bits also. This is how we will set the bit in how we will set the bit in 32-bit form. Okay. And if you want to clearly same process. So every 0 will represents each column. So like that, if I want to set logic 0 in these all the bits means I will give this hexadecimal form. So by giving this 0, all the bits will be changed into logic 0. If we consider I have to set the last 16 bits on it. So I am going to set these last 16 bits only. So last 16 bits means from 16 to 31. I don't want to set from 0 to 15. I want to set the 0 to 15 as a logic 0 and I want to set 16 to 31 as a logic 1. For that what we have to do? So each integer will represent each column. So for first last 16 bits, we will give 4f's. 4f means this is the sum of this value, and for this 2 columns also. So we will give 4f's and followed by 4 zeros. So this will set the logic 1 in this and last 16 bits and first 16 bits as a logic 0. So this is how we will configure the bits. This is how we will set logics in the bitwise form. So this is a concept you have to know because we are going to use the registers. So we are going to configure in this wise one. So concentrate in this because we are going to set in using the registers. Okay. So now we will get into, we are going to see how to write a particular bit and we are going to write it in the 20, 11, 3 and 2nd bit. So consider this is a 32 bit. So 32 bit is divided into 8 columns. So if I consider if I want to set if I want to set 20 here means 20 bit means I have to go 1 here. So 20 as a 1 and what is the left 11, 3 and 2. So 11 is here. So 11 also 1 and 3 and 2. 3 and 2 also 1. So we have a value of 8421 for each thing. So here there is a 0. So we don't want to set. So here is the value is 0. So here also 0. So we will see the 20th bit. Now we will see here. So what is the value here? First 3 is logic 0. That means it will not take these values. If it is the 20th bit is logic 1, then it will take this value. So that means it is sum of these 4 values is 1. That is what I have represented it. And we didn't set this 4 bits, so it will be 0, same as this 0. Now we will come to 11th bit. So 11th bit we have to set the 11th bit. So what is the value of the 11th bit? It is 8. So if I give the 8 means sum of this, because 4, 2 and first bit is not 10, 9 and 8 bit is logic 0. Only 11th bit is logic 1. So there is no value will be given for this. So only for 8. So I will represent it as a sum of this 4 is 8. So I have represented it as an 8. And now this is also will be 0. Now it comes with, now we are setting in 2 bits in the one column. So 2 bits means what is the value represents? It represents both 1 in 3 and 2. What is the values there? 8 and 4. And first bit and 0th bit consist of logic 0. So what is the value? It is 12. So sum of this 8 and 4 is 12. If I give 12, we can't represent, as I said in previous slide, we can't represent the 12 directly in the bitwise. So we have to represent in the alphabet. What is the alphabet for 12? It is C. So by using this hexadecimal way, we can set the 20, 11, 3rd and 2nd bit. Okay. Then this is a one way of setting the bit. But we are going to see another way of setting the bit, because when we use this method means it can disturb the other bits also. So you have to, one thing you have to consider, because when you are setting a bit or removing a bit, so you have to set or remove a particular bit only. You should not disturb the besides other bits, nearby bits. So for that process only we are using this OR operator. So if I want to set logic 1 and 20th bit means I will give an OR operator. OR means what it will do? If any of the output is 1 means it will give a 1. So it will compare with this 32 bit MISFR. And if I want to shift the logic 1 to the 20th bit. So if I give this left shift operator means from here it will shift to 20th bit by ORing it. And I am again also left shifting the logic 1 to 11th bit and 3rd bit. So by using this function we can set the particular bit what is we need. It will not disturb the other bits nearby it. Okay. So if you consider we have to set only the bit 20. So we can use two ways. One is this by giving hexadecimal way, and another one is by using a left shift operator. I am preferred this by using a left shift operator because it will not disturb the other bits. When you doing a minor calculations like a communication with I2C, SPA means we should not disturb the other bits. So we will use a left shift operator only. Okay. So next what we are going to do is, in previous slide we have set the bit logic 1 in 20, 11, 3 and 2. Now in this slide we are going to remove those, clear those bits. Okay. So we are going to clear the bit in 20, 11, 3 and 2 because they are those bits as a logic 1. So how we are going to clear? So simply you can use this hexadecimal. So it will clear all the bits. Okay. Then if I want to clear a particular bit, for that what I have to do? I am going to use a AND operator. So what is a AND operator? And in previous slide I have discussed the OR operator. What is OR operator? See here. So OR operator will, if any of the input is 1 means it will give a 1. When it comes with AND means if both the value input is 1 means only it can give a 1 output. So I am going to AND it with it. So I am going to AND it with 1. It is the NOT sign. So what is a NOT operator going to do? If I give input as 0 means it is going to give us a 1. If I give a 1 means it is going to give us 0. So what this is going to do is it going to AND this value with this bit. So going to AND this value with this 32 bit. So AND means what is going to 1 is going to be set in the 20th bit, and the NOT operator will change that 1 into 0, and the AND operation is done between these two things, and we will get an output. Now we will see how it works. Okay. So this is a definition how it works. Okay. We will consider first 8 bits only because we can't take these 32 bits. So we will consider first 8 bits alone. Okay. So now what I am going to do is I am going to clear the bit 3 only. I am going to clear this bit only, 3rd bit only. Okay. See the 3rd bit only because 3rd bit and 2nd bit has a logic 1, but I have to clear only the 3rd bit. So this is by using this function we can clear the bit. How this function works? Now we will see. So 1 left shift of 3. What it will be happen? Now the 1 will be left shifted to 3rd position of the bit. Then the values look like 4 zeros, 1 and followed by 3 zeros. And then it comes with the NOT operator. What is the NOT operator is going to do? It is going to change the 0 to 1. That means it will give a 4 zeros, 4 ones and 1 0 because here is a 1. So 0 and followed by 3 ones. Then the final step is it going to AND it with these MySFR old value and the one not of 1 left shift of 3. What is the AND value will be? 0 1 means it will be 0. 0 1 means it will be 0. So 1 1. 1 1 means it will be 1. But it is what is the bit? It is second bit. So we should not clear though that bit. So next bit is 3. So we want to clear this bit 20. So 1 0 here is 0 and here is 1. So 1 0 will give a 0. And 1 and we have 4 zeros and 1, it will also give us 0. Now we have cleared the particular bit in the third question. Now what we are going to do is we are going to clear the second bit also. So what we will do is this is a function. So first the MySFR will microcontroller will divide this AND with this operation, and the value of this will get ANDed with this. So what is the value of these two things? It is 5 zeros, 1 followed by 2 zeros. So it's going to AND it with this not of 1 left shift of 2. What is the 1 left shift of 2 is going to do? It's going to set the logic 1 in the second question, and it's going to not it. Not means what is going to happen? It is going to 5 ones, 1 or 0 and followed by 2 zeros. Now this value and this value will be get ANDed. What is the thing is going to happen? If the AND operator means both the inputs are same, means it is going to give a 1. So it is not same. So it will get a 0. So now we have cleared the third and second bit also. So this is how this is the method we are going to use for the register programming also. So we will set the UART pins. We will enable the UART by giving the logic 1 to the bit which is specified. So by this method only we are going to set and clear the bits in the logical ways. Okay. So now I am going to show how to read a bit. So as we were going to read the value from the 32 bit. So we can't take a separate, we can't read a separate bit. So when we come with the microcontroller, we should read the 32 bit completely. So what I am doing is, I'm going to read this value. I'm going to saving the value in the temp variable. Okay. So temp here is my data. Okay. So we are going to store this MySFR value in the my data variable. So now what we are going to see is we are going to check whether the 13th bit is logical 1 or 0. So what is it is present here? It is logic 0. So but we don't know, but we are going to check it. So for that I am already read this 32 bits, and I am going to give a if condition. So my data AND operate using AND operator, and I am going to shift the logic 1 to the 13th bit. So what is going to happen? That the 1 will come to this 13th bit. So this two things going to AND it. If the two things is going to AND means if here is a 0 and here is a 1. So what is the AND operator is going to do? 0 1 means the output will be 0. So if it is equal to 0 means it is 0, or else it is 1 means it will give a 1. This is how we will read the bit. Okay, so we can't read a particular bit. So we will read completely the total bit, and by that only, by the reading the total bit only, we will take the value from the which bit we are needed particularly. Okay, this is a procedure. So these bitwise configuration is a procedure for the register programming. So if anyone is not understand, can give me a message. If you understand means you can give me a thumbs up, or you can give me a like, anything. So we will get into the next concept. Okay. Now we will okay. What are the things we are going to see? So we are going to first set up the KEIL IDE setup platform, and we are going to develop the GPIO code, and we are going to get into the RCC clock registers, and we are going to see GPIO registers, and these are the things we are going to see in the upcoming sessions. First we will get into the KEIL Vision setup. So first we will set up the KEIL Vision ID. Okay. Before that about Panda. So our vision is to help the 10 million students to learn the technology in an easy way. So we will we are the educational equipment manufacturers. So we have IoT lab, we have EV design lab, AI innovation lab, autonomous vehicle lab, brain computer interface lab, embedded design lab, DCB lab, FPGA labs, DSP labs, And these are the things we have these kinds of labs. So by using this, we are developing a equipments for lab items and lots of projects is going on. So these are the pictures for some of the projects development boards we have created. Some of the boards is based on ARM and lots of ICs. Okay. So these are the things which are available in Pantech. So guys, if you need means you can place a order in this. So this is a product inquiry. If you want any some products inquiry related things, means first of all, what are the products you require? If you need some products, means go to Pantech elearning and see for what are the products you are available. And if you want some products, means you can contact this email, this sales@pantechmail.com, or you can contact this number directly for some products to buy. Okay. So what you will get is you can get some projects. What are the things we are developing is all AI or innovations, automotives, brains, embedded designs, PSB, all the things renewable energy design, all the things we are providing, we are developing this. So if you need some help means you can approach the Pantech e-learning. So we will develop we are the equipments manufacturers for embedded systems and lot of things. Okay. So now we will get into a KEIL ID. Okay. We will know how to set the KEIL. Okay, guys, some of them saying it is not understand. So, okay, I am going faster. Okay, I will try to go slower. Okay. Okay, I will give a last 10 minutes for a Q&A. So you can ask the questions. First, I will show how to set up the KEIL ID. Okay. So this is KEIL ID. So it is the interface of the KEIL ID. So first go to the projects and you have to select the folder. So you have to select the controller we are using, which is STM32f407. We are using is VG. And we have to on the Simpsons core and we have to give the startup file. So guys, if the Simpsons core is not available, means you have to install the package. Go to the pack installer here. Wait a second, it is loading. Okay. So search for STM32f4 series. In the series we are using is VG. Okay. So select this and you have to, it is already I have installed it. So if you not installed it, it will show us an installed key here. So install this and you have to, wait a second, this is loading. Okay. So you have to install this STM electronics STM32f4 series device support. You have to install this first, and Simpsons driver validation, and the common microcontroller software interface standard. You have to install these four things Simpsons, and you will have a middleware. Here is it. So you have to install these two middlewares also, KEIL middleware, MDK, two things for graphics and for professional. Okay. So after installing this, guys, you can see those things, Simpsons core activation, all the things. So after creating, it will be it has a source group. Right click this and add new items. .c of. So we will include the file. Okay. So you can see these libraries. So I am using is F407. So for checking if the library is installed or not, you can create this one. So now as the library has been installed. Okay, this is the setup. So in next class we are going to get into RCC registers, clock control registers, and we will start the PLL configuration and we will get into the system. Okay. So guys, so thank you for watching this. So guys, you have a 10 minutes of Q&A session. You can ask the questions in the chat box. I think today when started the topic very faster. In upcoming sessions, I will make it a little bit slower. When it comes to the coding part, it will be very much easy to understand. It is introduction, right? So you will be not able to get the thing. So by using, you get used to it, you will be able to understand the process. Okay, no problem, no issues with that. Okay. Prints, yes, you can use STM cube ID also. By and cube ID you can, it is it is available, all GPU will be available, but I'm not preferring that because we are in a learning stage. So when we are in learning stage, we should not use those advanced libraries. We should know what is registers, how the registers works, how the communication works. So we will use the registers. You can use the cube ID by you configure using the registers. Don't use the all GPU, all libraries. Okay. Yes, KEIL Vision 4 is also suitable. No problem in it. Okay. Software links will be provided. No, in next session I will provide a software links for the what are things I'm using. Okay. The internship link is already given in the slide. So guys, okay, I will next session I will send the links. No problem. Okay, guys. Okay, thank you. Now we will meet in next session. Okay, guys.